Good evening, everyone. This is your weekly dose of business analytics. How has everyone been doing?
Good, thank you.
Good. Good, thanks.
Well, very glad to hear that. So in week two, we have learned more about descriptive statistics. How much has the second homework bothered you so far? Okay, I received first question. One student asked about the meaning of group changes in categories, and also about mapping in question 2, part F. Have you encountered other questions?
Hey, Jerry, I also have one in terms of the Zhou's one, in regards to using standard deviation population versus sample.
Okay.
So that's also another one as well.
All right. Let me start my Excel file and homework 2 writing. So I'd also encourage you to do the same thing if that's the best way to spot any questions and understand the procedure. I have also made a shared Google file, Google Doc actually, for the review session notes. The link is included in the website, the Canvas webpage for TA office hour. You should be able to find it there under my picture. Okay.
Sorry, Jerry, I think I might have missed that. You said the recorded Zoom sessions, we can find them where?
The recorded Zoom session would be also in a web page under the module tab of the Canvas course website.
Got it, thank you. I'll take a look.
So your homework is due this Sunday, right? But you also have classes tomorrow, am I right?
Yes, that is correct.
Ah, I see. Yeah. Okay. All right. Let's start sharing my screen. So this is the shared Google Doc I mentioned in week 2. Let's see what are the items that we should discuss. Oh, so first, if you ever wondered what needs to be submitted, it's a PDF file of your Word document about the report writing. You are not required to submit any part of your Excel file. The sheets, cells, and functions and screenshots from Excel are never needed. So you don't need to upload any part of your Excel file. But sometimes you need to insert a chart. That's when we need to simply copy and paste the chart alone. If you need to summarize any tables, then we can insert a table. And I also included some tips about writing if you wondered what type of style you should follow. And if you need guidance regarding rounding statistics, then you can see more about these. I also included additional reference if you ever need to write reports for your profession, or needed to be more appealing. You can follow the guideline provided by APA, the American Psychology Association. The link is here, but these are not required for any parts of our course. So that's why it's listed under the beyond the course part. All right. So in week 2, we started.
Where this file is located? Sorry, where is this file?
This file is located in the Canvas web page for TA office hour. You will be able to find it in module for TA office hour. Oh, well, I will have to fetch my phone if I need to log into our Canvas website, but you will be able to find it there.
Okay, no problem. I'll find it.
So first part is a question regarding, glad to hear that. A question about z-scores. Has anyone have questions regarding z-scores?
Hey, Jerry, that's my question. I guess to clarify the question, so I was comparing the answer with my team, and we were in a discussion about, should we be using population or sample size?
Oh, okay. Great question. I also included a hint question here regarding what formula should be used when you calculate a standard deviation. So I believe the professor addressed this question by saying we should use population standard deviation.
Sounds good.
Yeah, so that's the short version. However, I would like to point out that in practice, we rarely use the formula for population standard deviation simply because we don't know it, and most of the time we need to estimate it. That's why we have to use the sample standard deviation nearly always. But for the sake of pedagogical purpose, I believe this time we are encouraged to use the population standard deviation formula. However, no matter which one you used, you will notice that it essentially makes very little difference in the results, simply because their formula only differ in the denominator by 1. And if our sample size is large, for example, in our COVID case example, we have 50 countries and areas, then one number divided by 49 or divided by 50 would be very close. So in addition to that, let's check out some other parts about a z-score. So we have learned the z-score formula, which is the original score subtract by its mean value. Then we need to divide it by standard deviation. So here, 2 things we need to check, which are first, the reference, about the difference between relative and absolute cell reference. Has anyone encountered problems or questions in this? Let's take an example. So for example, when I calculate a z-score for the total cases. This is the original score, and this C53, which is here on the 53rd row, is the average or the mean value, and the denominator is C54. Here, the C2 is a case of use of relative reference. That's when we do not use any dollar signs for either the column or the row index. However, if we put a dollar sign, for example, in this C53, it announces that this 53, the row index for average, will stand the same no matter where we autofill this formula. So that's why if we move to another row in the same column, for example, this one, we notice that this 53 row index stays the same. So as the row index for 54, because the mean value and the standard deviation for total cases will be the same no matter which country we are calculating the z-score for. All right. Item 2 for z-score formula use is that we need to pay attention to the priority of arithmetic operations, which means that we need to use parentheses in this case. Has anyone, if anyone did not use parentheses, you may find you got some misleading results. For example, for USA, if we did not use this parentheses, notice that currently the z-score for total cases for USA should be about 5. If we remove the parentheses, you notice that the calculation goes wrong. It's 82 million, well, 98 million. Then it'll be a incorrect answer. So let's get back. Okay, so in addition to that, we could use population standard deviation formula. How do we interpret a z-score? I would like a volunteer student to try and make a tentative answer to this question. How do you interpret, for example, this 5.42 for total cases of USA? Feel free to unmute yourself.
Hi, Jerry. It's
Hello.
Karen.
Oh, hi, Karen.
I will attempt.
Nice.
So that means that the standard deviation for USA is 5.42 higher. I'm sorry. Yeah, it's 5.42 higher than the standard deviation. Wait. I thought I had it. I think I lost it. Let me look at my notes. Which question was this for?
This question was not
You're just testing
any
us?
specific part of our homework question, but it's also important and essential to address some part of the homework questions. So my question was, how do you interpret a z-score for USA for the total case? Okay.
Yeah, I don't know.
Any help?
Can I take a stab at it? This is Tiffany.
Hi.
Hi. I'm going to save you here, Karen. Hopefully, I don't know.
You.
I might be wrong.
No
so
worries.
if we interpret that
You're all good.
z-score as it's 5.2 or 5.4 standard deviations above the mean number of cases.
Yeah, that's a good answer. So a good way to interpret a z-score is simply to follow the formula. We can find traces how we need to interpret it. Because we're calculating a z-score, using this formula. So when we interpret a z-score, for example, 5.42 for the USA total cases, we would interpret the total number of cases in terms of the number of standard deviation a observation is different from the mean. So in this case, the z-score we calculated for USA was a positive one. You notice that there are z-scores that are negative. So for a positive one, it means that the total case for this country, USA in this case, is above the mean. It's more than the mean. By how much? We divided this by standard deviation. So we could interpret it using the number of standard deviation. It is away or deviate from or different from the mean by this much of standard deviation. So putting it together, we could say that the total number of cases for USA is for 5.42 above the mean of all the 50 countries we had in the sample. All right, let's try another question. Does it make sense to compare these scores of different variables? Which means that if we compare this total case z-score to the total depth of z-score, does it make any sense to you? If we say this 5.42 is larger than 5.05. I would like another volunteer student to answer this question. Does it make sense to compare or subtract z-scores from different variables?
This is Tiffany. I'll just take.
Oh, hi, Tiffany.
I honestly have no idea, but I want to say no because it's two totally different variables that I don't know. That's my guess. No, not to compare them.
All right. Good try. I would also agree with you. So because the z-scores are calculated for specific variable, if you move to a different variable, which has usually a different mean and standard deviation, it's hard to compare between different variables, although we calculate z-scores for them using the same formula. Okay, another question. Does it make sense to take ratios of z-scores? For example, if we are comparing USA and India, does it make sense if we take ratio of 5.42 to 2.07, which will give us a ratio about 2.5, let's say?
No, it's Tiffany again.
Oh,
I want to
okay.
say no because again, it's measuring how many standard deviations they are from the mean. So I don't know that you can create a ratio on that based on that relationship. I don't think there is one.
Right.
Okay.
I would say I would agree that it's not a good measure.
Well, great thinking. I also agree with both of you. And another case that makes it stand out is that we noticed that there are cases where we have negative results of z-score. If we take a ratio between, for example, positive and negative one, we will also have a negative ratio, right? I don't know how we can possibly interpret that. So it probably won't make sense if we take ratios of these scores. However, I have seen students who calculate such statistics before. So
how about question, Jerry?
Hi,
If the z-scores are the same, let's say two countries have the same z-score for the same variable, what could we inference from that?
Oh, we could tell that they share the same raw value. So for example, for total case, the only chance that we observe the same z-score for total case is that the two countries would must have the same raw number of total cases. So we know that they share the same total cases.
The values, it sounds like, to calculate the z-score leading up to that would all have to be identical.
Yes.
Got it. Thank you.
Because as we see here in the formula, the mean and standard deviation stand the same, no matter which country you're calculating this z-score for, right? So if two countries share the same z-score, it means that they must share the same raw value, which is here, the xi. Okay, great question. Then let's also make a note that the score is for a specific observation, a specific country in our sample. So that's another note we need to understand. All right. After checking this z-score, we will also find that this z-score is nothing more than a transformation of raw values. We transformed raw observations by two procedures. First is to remove the mean, which is usually called centering. We center the raw values to 0, essentially. Then we scale it by dividing it by standard deviation. So now it comes to my follow-up questions. What's the average of these scores that you calculate? For example, for the total cases. Any quick answers?
Could you ask that question one more time, please, Jerry?
Yeah, sure. My question was, what was the average of the z-scores we calculated for a column, for example, total cases? And adding up to that is, what's the standard deviation of the z-scores? All right. We could simply move these here. Ooh. All right, I just made the practice for you by copying and paste the formula for average and the standard deviation from the raw scores to the scores. And we noticed that the average for these scores was 0. Standard deviation was 1. And this is the same for another column, which is about total deaths. Any comments on that?
Well, those are whole numbers. Would you say that that's accurate? Wouldn't we want to add some decimal places?
Very good question. Let's see how accurate it is. Let's increase the digits. How many? Okay, within 6 decimal places, it's still 0 and 1. Was this surprising to you?
Yeah.
Okay, feel free to calculate this for some additional columns. For example, later we also calculated a z-score for mortality rate, right? And some other additional statistics. Feel free to redo the practice for another series of z-scores. But we would find that this stands true, that no matter which variable we calculated the z-scores for, the average for z-scores would be always 0, and the standard deviation would be always 1. This is simply because we applied this formula. And follow-up question to that is, if a variable has a mean of 0 and a standard deviation of 1, does the variable follow a standard normal distribution? Would you say yes or no? Feel free to unmute yourself or comment in our chat room.
Yes, it does.
So one student said yes. Any other thoughts? Okay. The answer is no, or we don't know, or it's let's say in general, no. So although we learned something about standard normal distribution, where it says that if a variable follows a standard normal distribution, it will have a mean of 0 and a standard deviation of 1. But if we reverse the inference, then it doesn't stand. So if we know a variable has a mean of 0 and a standard deviation of 1, it does not necessarily follow a standard normal distribution. We can create an infinite number of different distributions which all share a mean of 0 and a standard deviation of 1, but none of them follows a standard normal distribution.
Jerry, are you saying that if it's the z-score had the mean of, or the average of 0 and the standard deviation of 1, then it would, but because we're looking at a variable, it does not? That's when it's no?
No, let me emphasize what I meant by what I said. So the answer to this question is no, which means if a variable has a mean of 0 and a standard deviation of 1, it does not necessarily follow a standard normal distribution. And Tiffany also made a follow-up inference, which has something to do with the next question. Do z-scores of a variable follow a standard normal distribution?
Yes.
Okay.
I don't know.
Tiffany, unfortunately, incorrect answer. This is also no. The answer is no. So although we have calculated the average and standard deviation for z-scores, right? And we noticed that the average would be 0, standard deviation would be 1. But it does not necessarily mean that these z-scores follow a standard normal distribution.
Okay, question here for standard, going back to the Excel spreadsheet, Jerry.
Okay, I can do that.
So are all of these z-scores a fraction of the standard deviation so that
Yes.
in total they equal the standard deviation?
I'm not sure what you meant in total they equal.
Well, they equal 1, I guess, in total, yeah.
You were talking about how or why we got this 1 in calculating standard deviation?
Yes. Are the z-scores a fraction of standard deviation?
Yes. It's a ratio in terms of standard deviation. Notice how we calculated these scores by dividing a standard deviation. By doing this, we guaranteed that the calculated z-scores has a standard deviation of 1, no matter what we subtract.
Okay, that makes sense. So why is the mean 0 though?
The mean is 0 because we subtract the mean from each observation.
Oh, okay.
Mm-hmm.
You just take it out of the equation. Okay.
Yeah. So although we learned that the property of these scores is that it has an average of 0 and standard deviation of 1. This is not sufficient to make the z-scores or the raw values to follow a normal distribution. So knowing that, let's practice this question. Does transforming a variable to its z-scores make the data approximate a normal distribution? Do you think it should be yes or no about this question? Oh, you have 5 seconds. Oh, wonderful.
No.
Want to try?
No,
Or maybe more.
I'll try for some wrong answers too. No.
Well, brilliant. I think you're becoming smart because it seems I lay out many tricky questions. And this one, unfortunately, did not get you. Yeah, so you got it correct. The answer is no. Transforming a variable to its z-scores will not make the data approximate a normal distribution. In fact, it won't change it won't change the distribution it follows. So this is where the effects of linear and nonlinear transformation have different impacts. So our z-scores is simply a linear transformation in a form of this. We only use multiplication and addition or subtraction when calculating this transformation. However, if we use nonlinear transformation, if we take, for example, logarithms or exponentials, this could potentially change the shape or the distribution of the raw score. Wonderful. Let's move on to pivot tables. Unless you have additional questions regarding these scores. I have included a few links for pivot tables, particularly about how to show data when the count is 0 and how to change the format of pivot table labels, which is for the second one, it is slightly not so straightforward. So the way I found most convenient is simply copy and paste the pivot table and make your own edits to the values directly. So let's take a practice. Have you used pivot table when in this homework, or has some of you not used pivot table in this practice?
I used the pivot table.
Okay. Let me take a look. I believe this pivot table was useful for some part in problem 2. When we address COVID questions regarding a frequency table. However, it's possible to get around to address this question without using pivot tables, but now it's a good time to pick up how to use a pivot table if you have not. Oh, okay. So in the pivot table, I believe the original question was regarding the mortality rate. Then we need to make a 1% bin of the mortality rates. So let's use this example here. I calculated the mortality rate for all the 50 countries and regions. So to make a pivot table, let's go to insert pivot table from table in range. Because we already selected, so it pops up here. And for convenience, I will generate the pivot table in the same worksheet. For example, here, right next to the raw table. So when we insert a pivot table, you will notice by default, it's an empty area that we need to populate. Because we are building pivot table for mortality rate, we need to first instruct Excel that the values should be calculated from mortality rate. By default, it gives you this, but it's not enough. So we need to also give it some ranges, which is most convenient if we put the range of mortality rates on rows. If you drag mortality rate to both rows and values, you notice that by default, it gives you the unique values of mortality rates. Because we have 50 countries and regions, this is by default also 50 of them, right? Yes, count is 50. But note that our homework question would like us to build a range for the mortality rates. This can be done by that we go to row labels, right-click any of it, and there's a field, there's a group option. This group option allows you to have a start. Let's put it 0. And in ending, let's put it 0.06, which is 6% by 1% interval. Okay, now we immediately have this table, but the values, instead of a count, we had sum by default. We can change this if we go to the pivot table fields and click this this value area and adjust the value field settings from sum in the summarize values by to count. You notice that there's another option saying count numbers. These two would be different if there are characters or sentences if you included in any of the cells. But in our case, it won't make a difference. So let's select count of mortality. So you notice that each of them would be an integer number of the number of cases in this range. However, some of you might have already noticed that this range in the row labels are not continuous. There's one missing. There was no country between 3% and 4%. So by default, Excel would ignore this row. So we could still let it show by going to any of the row labels, just like how we instructed to make this group. We would go to field settings, and there's another tab, layout and print. There's a check we can make for show items with no data. Upon that, you notice that this table changes by having another row for 3 to 4%. But by default, it gives us 0. It gives us an empty cell for the count. So what if we want the count to show up exactly as 0? This can be done if we go to, let's see. Okay. If we right-click to the count of the mortality rate area and go to pivot table options, in the layout and format, there's an option for format. For empty cells, show what? We can put 0 in it. And you notice that each of these 3 cells that used to be empty had zeros populated. So if we need to build a histogram out of this, and we wanted the row labels to, instead of showing fractions, but a percentage, it's somewhat not so straightforward. The best way I found is copy and paste. So select copy and paste the values for this pivot table to another area. Then we can manually change all these labels to something that we want. For example, 0%, to 1%. Then you can apply such changes to, let's see, oh, well, it's not that smart. But if we populate another row, let's see whether it can autofill all the other rows. Well, unfortunately, it doesn't. So it seems that we have to manually adjust each of them. Unfortunately, I have found no way to that Excel would automatically change this format of row labels to percentage. So if you must use that, then it probably requires manually change. Are there any questions about pivot tables? All right, let's move on to Excel charts. There are a few different types of charts we are required to make in our homework too. The first one I notice is a box plot. So it's built here, right? Has all of you already constructed this box plot? I would like to challenge you to interpret such a box plot. Okay.
Hey, Jerry, I can take a stab at it. Starting from the top, the weird circle thing at the very top, that looks like a weird outlier. It might be, I think it was like that one of that health company up there.
Okay.
The top line.
Correct. So who was it? Let me.
It's Vivian.
Oh, Vivian? Oh, okay. I'm glad to have you here. So as Vivian said, these points are outliers. I will explain more about why we recognize them as outliers later. But the points represent outliers in a box plot. Okay, move on, please.
Sure. Actually, sorry, quick question. In terms of those outliers, do you want us to point those out in our interpretation, in our homework questions?
I'm not sure whether it's required. If it says that you need to, explain something about outliers, you should do so.
Okay.
Otherwise, yeah, just follow up follow the instructions in the homework questions.
Okay, sounds good. So there's that upper line right here.
Okay, yeah. What about let's say top whiskers? What does this horizontal line represent?
I'm gonna guess the Q. So all of these are quadrants. So I'm just gonna guess that this is the upper part of Q4 quadrant, and then
okay.
Oh, go ahead.
Yeah, unfortunately, it's an incorrect interpretation of this specific representation. Okay. As I, let's see, did I mention it somewhere in this? Oh, okay, this has something to do with IQR, the distance between the first and the third quartile. We notice that this distance, the length of this whisker, or let's say the height of this whisker, is 1.5 of this height of the box. That's how this whisker is constructed, 1.5 of the height of the box. All right, yeah, but good try, Vivian. How about the top border of the box? What does it represent?
I'm gonna guess that's like, that box is like the middle 50%.
You're getting close, but I'm specifically asking about the top border. There are 3 parts you can read from this box, the box part. the middle darkened area. There's a top border, there's a middle line, there's also a bottom border.
Is the top border Q3?
Oh, yes, correct. That was Tiffany, I believe. She got it right. This top border represents the third quartile, which is also the 57th percentile, or you can say it is the 0.75 quantile. They are equivalent meaning of the same stuff, essentially. All right. If we know that, how about the middle line? Any tentative answers? What does the middle line in the box represent?
The median.
Correct. Who was that?
Manoj.
Oh, Manoj. Okay. Wonderful. So he's right that the middle line represents the median. How about the bottom border?
Is that Q1?
Oh, correct. That was Vivian again, I believe. So Q1 means the first quartile, where the difference between the first 25% of the data and the rest lies. How about this bottom whisker? Oh, hi. Was there a question?
Karen. Yeah, I'm looking at the textbook and it says the bottom one is Q3 and the top is Q1. Do these change depending on the information?
It changes depending on whether you put the higher scores in the top or at the bottom. So if you flip this this vertical axis, then it's possible that am I still sharing my screen? Are you seeing my Excel sheet? Okay, yeah. Somehow my screen. Okay, it changes a little bit. Okay, so if we flip this vertical axis to show 0 at the bottom and 600 at 0 at top and 600 at the bottom, then it's possible that we switch. So notice that which one represents higher scores. So the first quartile is always smaller than the third quartile. I think that's a good way to recognize why or how it could be different from different charts. Does it answer your question, Karen?
It makes sense what you're saying, but the book, for some reason, has Q3 at the bottom, and that is the lower numbers.
Oh, but does it also have the same, let's say, same trend on the vertical axis? So the smaller scores would be lower, and the larger scores would
be on the top,
stay higher. Oh, yeah. Okay. It could be typo or error in textbook. Yeah, in such a large textbook, it's not uncommon to have a few typos. Yeah, but we need to understand that the first quartile should be a smaller number than the third quartile. If we are talking about negative numbers, then it still applies. The third quartile would stand on the axis at a higher or larger value than the first quartile. Okay, then it comes to the last item for a box plot, how to interpret this bottom whisker. Any tentative answers?
Would that be the outlier on the other end?
Good try. Unfortunately, no. So remember what, as we discussed earlier, outliers are represented by points. We do not see any particular points, so it does not represent an outlier. I saw that another student attempted to make an interpretation.
Well, we said the top one is like the maximum value of the not necessarily the data set, but of that. So I don't know, I guess it would be the lower value. So the opposite of what we said for the top whisker.
Okay, you're getting almost there. So in this particular case, this bottom whisker represents the minimum value. So the minimum, let's see, we will find out by making a filter and go to price. Minimum would be about 27. But regularly, this whisker, as we practiced earlier about from the top whisker, is built by 1.5 of the interquartile range, which is the distance between the first and third quartile. In this case, it's illustrated by the height of the box, the darkened area. However, we notice that the height of this line is not as long as 1.5 of the box height, right? Because we do not have any data or data points lying below this much, which is its minimum, right? So, and because we do not have any outliers, so this whisker does not go beyond what it could. But on the other hand, if we go to the bottom whisker, because we do have an outlier, and this 1.5 IQR interquartile interquartile range is still within the range of the observed value. So that's why this bottom whisker and the bottom whisker and the top whisker represent slightly different meanings in this case. The bottom one is the minimum value, and the top one is built by 1.5 of the IQR. All right. Any questions regarding box plots? Well, I have one for you. What criterion or criteria did you use to find outliers?
Other than you said it's represented by a dot.
Good point. So did you use this method?
The chart.
Yeah, one way we can find outliers is through a box plot in a chart. So as we discussed earlier, this outlier is any value that lies beyond the whisker, right? So in this case, the whisker was built, the top whisker was built by the IQR. So that means the outliers has a criteria that anything beyond this whisker, the 1.5 IQR from the third quartile would be all outliers. However, in the textbook or in the lectures, we also learned that we could also recognize outliers by calculating z-scores. Has any of you done outlier finding in this way by calculating z-scores?
So with the z-scores, what I did is, well, I also had a value for the mean, for the average, and then the z-score, and then I sorted it to highest to lowest. So you can see the highest z-score was way higher than the next score of clusters, which was closer to the means.
Okay. Karen, could you elaborate about the z? Oh, okay, here. Did you calculate the z-score for the price?
Yes, and then I sorted it so that I could have it in order.
I see.
Lowest to highest.
Wonderful practice. You could also find such unique values by going to the filter tab. So what criteria did you use to pick outliers from these scores?
I compared it to the medium. I just used a visual, I guess, where I saw that the number was significantly different than the rest, or away from the rest, that it was clearly going to be an outlier.
Ah, okay, I see.
When I sorted it, you could see that most of them would fall like between 0 and 1, and then there was one that was like a 5, or so it's significantly off of the chart.
I see. Good practice. However, there are some conventional thresholds we can use. So for these scores, when we talk about thresholds, usually it's -3 or +3. So if the score is beyond that, then usually we recognize them as outliers. However, in some other practice or reports, they could use outliers by 2 in the score. So if it's below -2 or above 2, then they can recognize them as outliers. So it depends on the sensitivity we want. So good try. To find outliers, we could either use a box plot and a z-score, but they use different criteria. Make sure you understand how outliers are defined. All right, let's move on from box plot to histogram. We are required to build a histogram so that the mortality rate is between 0 and 6%, and each category covers 1%. So a good way to check whether the chart you made comply with the requirements is to check individual elements. So for example, how many bins your chart has, and are the bins intervals continuous? And there are also ways to adjust bin intervals if we build histogram. And there are also, some students noticed that the histogram they built from pivot table looks different than those built from an automatic histogram. I found the reason. It's because how the intervals were defined in these two functions. They are different. In pivot tables, the interval has the left limit included, but in histogram, the right limit is included. That's why for some individual observation, it'll be included in the, for example, the first bin in pivot table, but when in the automatic histogram function, it'll be in the second bin. They look similar, but the count would be slightly different. Did any of you use different functions for building histogram? So are you all good with histogram?
Oh, Jerry, I guess like my question for histograms. Mm-hmm. Yeah, this is for 3B when we talk about the stock market.
Okay.
There's a request in terms of building a histogram, and we are supposed to group these changes in categories that cover 1 percentage point. Mm-hmm. I guess when I try to do that, it's just like a climbing uphill when creating one based on changes, but it looked a little bit more like, like those candlestick stock figures when they would do it by time series. I guess, could I get a little bit more of an idea what you're looking for the changes?
what I am looking for.
Is this it?
Yeah, so I'm showing the example I have here for the stock market changes, right? So it's a histogram. It shows nothing but frequency. So just like how we build the histogram from a pivot table for the COVID cases, like this, mortality rate, the histogram for stock market price change would look very similar. So this is how we calculate the count of percentage change. Then we use this to build a histogram.
Got it. Okay, that actually makes sense. Thank you.
Wonderful. Then it comes to our last item we need to check. Oh, these are some help file related items that I find to be useful when checking whether a plot created is correct. So one thing really important is that we need to make sure that we use the correct variables. So always check which variable is used on the horizontal and the vertical axis. So for example, when building a line chart, read what the horizontal and vertical axis represents. When you click a chart, usually the columns from which a chart is built is highlighted. So make sure they point to the right columns as desired. Another checkpoint is whether the ranges match. So we can check for each axis. For example, in this S&P 500, we notice that the horizontal axis ranges from 0 to 120. And the vertical axis points ranges from somewhere about 1,500 to about 5,000. So you should check this against the observed data. Sometimes the automatically built charts do not align everything correctly. So make sure the range match. Oh, okay. Another good way is to check some individual elements. This is particularly useful when we build histograms. So for example, here, we already observed that the mortality rate has no countries or regions in the bin of 3 to 4% of mortality rate. But if your case has any observations in this range, then it means it's incorrect. So we can also spot any mistakes or errors if we go to individual elements of a plot. Are there any questions regarding building charts in Excel? Wonderful. If not, it'd be great. All we have discussed should be sufficient to address the questions about homework 2. However, if you have additional time, feel free to check out other notes that I lay out based on what we learned in week 2. Some items that's worth checking is where can we use these scores? And probably next time, if we have additional time, I can show you some of the visualization and the data exploration methods I have used. And in addition to the guidelines for statistics reporting and tables and figures, there are also some common data exploration procedures you can follow in addition to what we learned in this week. And in the last question in our homework, we are challenged to discuss about lies in statistics. In my field, I noticed that there are two major areas when researchers and interpreters or readers can make mistakes. One is so-called as p-value hacking, also known as data snooping and data red dredging. This is where we can fake significant findings when there's none. There's another series of statistical lies people often make. That's when interpreters, especially news reporters or journalists, mistake association with correlation or correlation with causation. Each of these three are different. There's a short journal article regarding the differences between these three concepts, and there's also a blog summary. I encourage you to check them when you have additional time. However, none of these parts are required to be successful for homework questions or exams. So no worries if you don't check any part of the Beyond the Course section. This should summarize what we need to review in week 2. I hope to see you again next week.
Awesome. Thanks so much, Jerry.
Bye, Vivian.
Thank you, Jerry.
Thank you very much. Bye.
Thanks. Bye. Bye.
Bye.